The random in math class. A class library is a collection of classes that we can use when developing programs. The Java standard class library is part of any Java development environment. Its classes are not part of the Java language per se, but we rely on them heavily. Various classes we've already used, like system, scanner, and string, are all part of the standard class library. The Java class library is sometimes referred to as the Java API. API stands for Application Program Interface. Clusters of related classes are sometimes referred to as specific APIs, like the Java FX API and the Database API. Get comfortable using the online Java API documentation. Packages. For the purpose of accessing them, classes in the Java API are organized into packages. These are often overlapped with specific APIs. Here they give you some examples. The Java language package is general support. The Java UTIL package is utilities. The Java.NET network communications. JavaFX scene.shape is graphical shapes. JavaFX scene.control is GUI controls. When you want to use a class from a package, you could use its fully qualified name, java.util.scanner, or you can import the class and then use just the class name, import java.util.scanner. To import all classes in a particular package, you can use the wildcard character, which is the asterisk. All classes of the java.language package are imported automatically into all programs. It's as if all programs contain the following line, import java.lang.star. That's why we didn't have to import the system or the string classes explicitly in earlier programs. The scanner class, on the other hand, is part of the java.util package and therefore must be imported. So I created this program to demonstrate the different ways we can import a class. So the first way I'm going to demonstrate is the way that I've been doing it, where I just import the class through the package name. So I import and then I use this package and then I use the class. So I'm using the scanner class here. I'm creating the scanner object. Then I created a variable to hold a name. And then I prompt the user for his name, store the name, and then output the name back to the user. I'm going to go ahead and compile and run this program. Really simple program. Enter my name and I get an output. So I was able to use the scanner class only because I imported the scanner class. But if I were to remove this line where I'm importing the scanner class and try to compile, I would run into a problem. The issue I'm seeing is Java cannot find the scanner class. It doesn't know anything about the scanner class. And the reason it doesn't know anything about the scanner class is because I never imported the actual class. So if I want to use this scanner class, I either have to import the class or I could use a full package name whenever I use a scanner class. In order to do that, we have to put the package name in front of scanner whenever we use scanner. Now I put the fully qualified name of the scanner class so that Java won't be confused on where the scanner class lives. So now Java knows to look in java.util package to find this scanner class. So now when I compile, there will be no errors. I'm going to go ahead and run the program as well. And I get the same results. The next way to use a class is to use the wildcard in the package. Whenever you use the wildcard, you're basically telling Java that you want to use everything from that package. So I went ahead and used the wildcard to import everything from the java.util package. And I went ahead and uncommented this line and I commented out this line right here. So this will work exactly the same. So I'm going to compile and run. And you see I got the same results. There's 3 different ways to use a class from a particular package. The first way is just importing just the class you want to use. The second way is to use the fully qualified name. And the third way is to import the entire package using the wildcard. The random class is part of the java.util package. It provides methods that generate pseudo-random numbers. A random object performs complicated calculations based on a seed value to produce a stream of seemingly random numbers. See randomnumbers.java. In the book, here's the documentation for the random class. You have your constructor. You have nextFloat, which returns a random number between 0.0 inclusive, that means it's going to include 0, and 1.0 exclusive, meaning it's never going to include 1. Then you have the nextInt, returns a random integer that ranges all over the possible int values. So all the possible values for an integer are randomly picked. And then you have nextInt where you pass in a number. This returns a random number in the range of 0 to the number -1. Here's an example of how they're using the random class. So they import the random class up top with the import statement. Then what they do is create an object reference variable and instantiate a new random object. They create variables to hold numbers. Then they set num1 equal to a random object nextInt. And then they set num1 equal to random object nextInt, but they pass in 10, and they have their output right here. And then they keep doing this, like they add 1 to it, then they add 20, subtract 10. So they're giving you a range of what random numbers that are going to be generated. Then they generate a random number using nextFloat. So this is going to be in the range of 0 to 1, but not including 1. Then they generate a random number by multiplying it by 6. So the possible values is 0 through 5.9999. Then they cast the float result to an int and add 1 to it. So instead of getting 0 through 5, they're getting 1 through 6. And here's the output. So I created this class so that I can demonstrate the random class. So the first thing we need to do is we need to import our random class from the Java U2IL package. Now that I've imported my random class, I want to go ahead and create an object reference variable and instantiate a new instance of random. So here's my declaration and instantiation of the random object. Now if you notice, you don't pass anything into the parentheses. So this is just like when we instantiate our scanner object, except we're not passing anything into the constructor of the random. So now that I have an instance of the random object, I want to go ahead and generate some random numbers. So I'm going to go ahead and make an output and output some random numbers. So I created this output, and what I'm doing is I'm taking my random object and I'm invoking the method nextFloat and nextInt. So I'm going to go ahead and compile and run this program. When I compile and run, you can see that I got a random number for nextFloat. Now if you remember, the range for nextFloat is 0 to 1, but not including 1. So all possible values for a float between 0 and 1. And the range for an integer is all possible values for an integer. So this can be a big negative number or a really big positive number. Now, every time I run this program, these numbers are going to be different. So I'm going to go ahead and run this program a few times so we can look at the results. So the random class is generating pseudo-random numbers, but this is really not doing anything for me. Now, in most cases, if I want to generate a random number, I want it to be within a specific range. If you look back at the slides, the method I want to use is nextInt, but I want to pass in an integer, and this integer is going to represent how many numbers I want. So whenever you invoke the method nextInt, the value that you pass in is the total number of numbers that you want to generate. So for instance, if I pass in a 10, I'm going to generate 10 random numbers, but I'm going to start from 0, and my highest number is going to be 10 minus 1, which is going to be 9. So I'm going to generate 10 random numbers that include 0 and include 9. So I'm going to go ahead and create an output statement that's going to generate 10 random numbers between 0 and 9. So I added this output statement, and all I'm doing is just taking my random object and invoking the method nextInt. I'm passing in a 10, so that's telling this method that I want to generate 10 random numbers. So the range for that is going to be 0 through 9. So when I compile and run, as I keep rerunning this program, you'll see that the numbers that are being generated are between 0 and 9. So there's my result, 6. I'm going to keep just running this program. So every time I run this program, you can see that the value keeps changing. The number is between 0 and 9. Now 0 is supposed to be included in this generation. So instead of me sitting here and running this program over and over and again, I'm going to go ahead and create a loop, but I'll make this loop so that I could run this line of code several times and we can see the output. I created this loop, and we'll talk about loops in chapter 6. This loop is going to run the statements inside of this loop 25 times. Now I went ahead and I moved my random number generation to be assigned to a integer variable named num, and then I'm simply just printing out that num in this output statement. Now when I run this program, it's going to run the statements 25 times, and we'll see all the different generations of those 25 iterations. Alright, so I ran my program, and right here is where it started generating the random numbers. And if you notice, since we only passed in a 10, our range is 0 through 9. And if we scroll down, we can see we get a lowest value of 0, we get a high value of 9, and all the generations, they're all within that range. So I modified this program a little bit. I went ahead and took out the original statements I had in here and copied them and pasted them up here. And I left a note here that says gen random number between 0 and 9. That way when you go back and look at this code, you'll see what I used in order to generate that range. But let's just say now we want to generate a different range. Let's just say the range that I want to generate is 1 through 10. So when I generated 0 through 9, I passed in a 10. I was telling the method that I want 10 random numbers, and those random numbers are from 0 through 9. If I want a range of 1 through 10, then all I have to do is add 1 to this result. So now when I compile and run this program, you'll see my range will be 1 through 10. So I compiled and ran my program, and if you look, this is where I'm in my loop generating numbers. Now I changed it to where I'm generating values between 1 and 10. If you look at the random results, my highest value is 10, my lowest value is 1. I keep scrolling down, and you can see that all the values that were generated are within that range. So I'm going to go ahead and move this code out, and let's do a different example. So let's just say I want a range of random numbers between 17 and 24, including 17, including 24. Now looking at this, we might think that there's only 7 numbers, but since we're including 17 and 24, there's actually 8 numbers here. I'm going to go ahead and list out all possible 8 numbers. So I listed out all possible 8 numbers, and I put a count of each one. That way we know for certain how many numbers there actually are in our range. So if there's 8 numbers, this means in our next int method, we're going to pass in 8 as the value. So the method is going to look like this. So as you can see, I'm passing in an 8. So if I'm passing in an 8, that means my possible values will be 0 through 7. Within 0 through 7, we have 8 numbers total. So if I wanted to range 17 to 24, then what I have to do is actually add 17 to this range. So if I add 17 to this range, range, then I'll simply just add 17 here in the code. In doing so, it's going to result in a new range. And that new range is 17 through 24. So let's add this to the code. I updated my code so I can generate a random number between 17 and 24. So what we talked about is putting an 8 here. Adding an 8 would mean that the random number generated in what's highlighted would be 0 through 7. So if I add 17 to 0, then my lowest value would be 17. Now my highest value in what's highlighted is 7. So if I add 17 to 7, then my highest value would be 24. So I'm expecting a range of 17 through 24. Let's go ahead and compile and run this program. And here are my results starting here. So I have an 18 there, I have a 17 there, 24 there, and it looks like I don't have any values outside of that range. So I was able to generate the range of 17 through 24 by passing in an 8 and adding 17 to it. So coming up with the numbers that I use within my next int to get this range, it might have seemed a little difficult, but we can actually write an equation for this. So I'm going to go ahead and show you an equation that you can use, and you can get any range that you want if you stick to this equation. So let's say we want to generate a random range from our min value to our max value. It can be any value here. This can be 10 through 100 or 1000 to 2000. It doesn't matter. The only thing that matters is if you plug in your numbers correctly. So you want to range from min to max. So we need to figure out what we pass into the next int method and what we offset that value by. Now the offset is the simplest thing to figure out. The offset is always going to be your min value. Now what goes into the next int method is a little more difficult to figure out, but it's essentially the number of numbers that you want to generate. So what we can do is we can take our max and subtract our min and add 1. And that's going to give us the total number of numbers. Since we're including our min value in our range, it's always going to be the difference between max and min plus 1. So there's my equation. Now I can figure out any range. So let's just say I want to figure out the range of 10 through 99. Using what I just did up here, I'm going to take my max, 99, subtract 10, and add a 1 to that. And that comes out to be 90. My min value for this range is 10. So if I wanted to generate a random number between 10 and 99, then my code will look like this. So here's a line of code. I pass in 90 from what I figured out right here, which is the max minus the min plus 1. And then I offset it by 10, and 10 would be the min value. So I'm going to add the 10 right there. And now I can use this line of code and generate a random number between 10 through 99. So I added my code where I pass in a 90. That's going to give me the values of 0 through 89. So whenever I get a 0, if I add 10 to that 0, I'm going to get 10. Whenever I get 89, if I add 10 to that value, I'm going to get 99. So this is going to give me the range of 10 through 99. So I did increase the number of times I iterate this loop to 1000, and that's because I have a bigger range and I want to make sure that I see all the values within my range. So let's go ahead and compile and run this program. So I compiled and run my program, and I'm just going to kind of look through these values and see if I see my 10 and see my 99. I'm going to verify that no value is outside of that range. So I have a 10 there, I have a 99 there. And as I look through this, I don't see any values outside of that range. I think it would be pretty obvious if we went outside of 99 because that's going to be 3 digits. And I think it'd be pretty obvious if we went less than 10 because it's a single digit, and it would be obvious when we look at it that there's a single digit number. So that's it. You can use this equation here to get any range that you want. The difficult part is figuring out what you're going to pass into the next int method, but it's simply the max value you want minus the min value plus 1, and then you're always going to offset by your minimum value. So now that I've showed you the equation to generate a random number, let's do a quick check. So looking at the following expressions, what's the range that's going to be produced? So this first one we're passing in a 25, so that range is going to be 0 through 24. Right here, this is going to be 0 through 5. We're going to add a 1 to it, so that's going to be 1 through 6. Right here, what's highlighted is going to be 0 through 99. But we're going to add 10, so that's going to be 10 through 109. What's highlighted is going to give us 0 through 49, but we're adding 100 to that, so that's going to be 100 through 149. So here's an interesting one. So what's highlighted is going to give us the range of 0 through 9, but we're subtracting 5. So we subtract 5 from 0, we're going to get a negative 5. When we subtract 5 from 9, we're going to get a positive 4. So the range is going to be negative 5 to positive 4. This next one, we're going to get 0 through 21 as our range and what's highlighted, and then we're adding 12 to that. So we're going to get 12 through 21 plus 12, which is 33. Let's look at the results. Here are the results, and they're all within the range that I predicted. Now we're going to do the reverse. So write an expression that produces a random integer in the following ranges. So if you want a range of 0 to 12, we're going to pass in a 13. That's the easy one. If you want a range of 10 through 20, we're going to pass in a 20, but we're going to add a 1 to the result. If you want a range of 15 through 20, now this is where we can use our trick. So we take 20 minus 15 is 5, plus 1 is 6. So we're going to pass in a 6 into the next int, but we're going to offset it by 15. So here's an interesting one. Negative 10 to 0, where negative 10 is your min value and 0 is your max value. We can still use the equation that I generated, but I should have actually added in the absolute value of the difference. The difference here is going to be 0 minus negative 10 is going to be negative 10. We take the absolute value of that, which is 10, right? Because there's 10 numbers between 0 and 10, but then we add that 1 because we're including the 10, the negative 10. So we're going to get 11. I don't know if that makes sense, but I'm going to hop back over to this and I'm going to go ahead and update this where we're going to take the absolute value of max minus min. So we want to find the absolute value. So if you're dealing with negative numbers, you want to have the difference positive so that you don't have any negative numbers that you pass into next int. Because you pass a negative number into next int, you're going to get an error. So coming back over here, we take the absolute value of 0 and negative 10. That's going to be 10. We're going to add 1 to that. That's going to be 11. And then our offset is going to be negative 10 because we want a negative value. So we're going to put a minus 10 at the end. So let's look at the results. So the first one is what we expected. So is the second one. So is this last one, but we used the equation to kind of figure this one out. We also use the equation here, but we use the absolute value to figure it out because the difference between 0 and negative 10 is 10, and then we added a 1 to that. And then instead of adding a 10, because my min value is a negative number, I'm subtracting 10.